For 6.2, we're doing standard units and areas under the standard normal distribution. So first off, we're looking at our z-scores. So a z-score is same thing as a z-value. What you need out is that chart packet that I gave you. It says like a z-table on it, and it has t-table, and it's stapled together because you're going to be using that table as you go through these. Because that table is going to give us certain probabilities that go with these certain z-values. So your z-value or z-score gives the number of standard deviations between the original measurement x and the mean mu of the x distribution. So it compares your original mean and it compares then your value that you're looking at with your standard deviation. So it kind of gives us a value then that we can find probabilities with. It makes them all similar to each other so you can compare amounts. So we can change it to this z-value so we can find probabilities then that match up with this z-value. Now, if the x value is equal to the mean, so if in your story problem you have a number that's equal to your mean, your z is equal to 0. Every time, if your value is same thing as the mean, it's equal to 0. If your value is bigger than your mean, your z is going to be bigger than 0. So you'll have a positive z. If your value is smaller than your mean, you're going to have a number less than 0, so you're going to have a negative z. Again, we are going to get to the chart, and I have a chart here ready for me too on my screen, so I will go back and forth to that when we start looking at it. So we're not at the chart yet, but we're going to use that formula to find what our z value is. So here I got a pizza franchise specifies that the average or mean amount of cheese on a large pizza should be 8 ounces and the standard deviation only 0.5 ounce. An inspector picks out a large pizza at random in one of the pizza restaurants and finds that it is made with 6.9 ounces of cheese. Assume that the amount of cheese on a pizza follows a normal distribution. If the amount of cheese is below the mean by more than 3 standard deviations, the parlor will be in danger of losing its franchise. How many standard deviations from the mean is 6.9? Is the pizza restaurant in danger of losing its franchise? So if we're trying to figure out the number of standard deviations, you are finding your z value because that tells you how far away you are from your mean. So when I go through this then, I need my z formula. So x minus the mu over sigma. In your problem, they tell you that the mean is going to be 8 ounces. The standard deviation is 0.5. They are telling us we're looking at 6.9. We have to compare 6.9 with the mean and the standard deviation. So 6.9 is going to be your x. 8 is your mean. Standard deviation is 0.5. Now when you type that into your calculator, you must do 6.9 minus 8, hit enter, then hit divide by 0.5. Because you want to make sure your calculator does the correct order of operations. Now when it does that, you should get negative 2.2. So they want to know how many standard deviations that is from the mean. That would be 2.2 standard deviations from the mean. It's going to be to the left of the mean because it's negative, but it is still 2.2 standard deviations from the mean. So it's in danger of losing its franchise if it's more than 3. So if it's more than 3, that means we would have a positive 3 or a negative 3 for our z value. Well, negative 2.2 is inside that range of 3 to negative 3. It's not outside of it. So no, they would not lose their franchise. Again, if you would lose it, it would have to be outside of the 3 to negative 3 range. Now we have a formula to find our z value. We also have a formula to find our x value. Because sometimes in the problem, they might give you your z value, your sigma, and your mean, and you've got to find what is the original x value that goes with it. What's the number that goes with it? And we're going to go through and use these two formulas over and over and over again as we go through all of Chapter 6. So when we get to 6.3, we do this a lot. So you need to really make sure you know your two formulas, your z equals and your x equals. Those are the two main formulas for this section. So I would have those written down somewhere. I would make sure they are in front of me as I'm going through 6.2, 6.3, and then again in 6.5 also you use it again. Okay, so this one is very similar to what you just did with me in example 3. Part B is new for us, but I want you to do part A. I'll come back and do part B with you, but I want you to do part A. So pause the video, go through part A, find the z value. So we should have a number then for A here. So you're telling me what the z value is. So here it says, Rod figures that it takes an average or mean of 17 minutes with a standard deviation of 3 minutes to drive from home, park the car, and walk to an early morning class. One day it took Rod 21 minutes to get to class. How many standard deviations from the average is that? Is the z value positive or negative? So you are solving for your z if they want to know how many standard deviations. So your z is equal to x minus my mu over my sigma. So when it says it took Rod 21 minutes, that's your x. That's what we're testing against our mean, which they told us our mean was 17, and our standard deviation, which is 3. So again, type that into our calculator. And then you should have gotten 1.33. So when they ask how many standard deviations away from it, it would be 1.33 standard deviations from the mean. Then they want to know, is the z value positive or negative? We got a positive number because 21 is bigger than our mean. So if we're bigger than the mean, you're going to have a positive number. Now for part B. If you tried this, good. If not, it's okay. We're going to go through this. They want to know what commuting time corresponds to a standard score of z equals negative 2.5. So they are saying, what does x equal? Whenever they give you z equals, you have to turn around and find the x. So that was the formula from the front page also. So x equals z times sigma plus our mu. So you're plugging everything in. They told us we have negative 2.5. We've got a sigma. It told me a standard deviation of 3. And they told us our mu for our mean was 17. So all you're doing is taking all of your information, plugging it into your formula. Again, if they give you a z value, you have to find the x value. So when I plug that in, we get about 9.5 minutes. So now if you would put 9.5 in for x back in the z formula, you're going to end up with a z value of very close to negative 2.5. So you can always go back through and check yourself when you solve for x, plug it back into the z, and make sure that you get the z that they gave you. Okay, standard normal distribution. The standard normal distribution is a normal distribution with a mean at 0 and a standard deviation of your sigma is 1. The area under the standard normal curve gives the probability that the measurement of an item selected at random falls into the interval. So when they talk about this standard normal distribution, we're going to have a special table with it. That's the table I told you to get out. And I'm going to have mine pop up too so we can look at it together. So we're going to practice using the table here. So in example 4, it says use your table. I'll always call it the z table because it says z at the top there, to find the described area under the standard normal curve. So it says find the area under the standard normal curve to the left of z equals negative 1. So I'm going to go to my chart here. So you have this pretty picture here. When we go through this, the numbers inside of your chart, If you read the little picture over here on the left, it says, table entry for Z is the area to the left of Z. So all of these probabilities in your table represent the probability of being to the left of your number. You have to remember that. It's very important. Every single one of these represent to the left of your Z. We have to do some manipulating if the problem says find it to the right of your Z. So you need to make sure you pay attention as to if they want left, right. Sometimes they'll even say in between two values. But the main thing right now is we want to find the area under the standard normal curve to the left of negative 1.00. So you need to look in that first column here where it says Z. They have negative numbers. So if I scroll down here, I can find negative 1.0. So it's right down there. Now, what you're looking for is then in the next columns, the 0.00 column, because that will match up with negative 1. So you need to look for the negative 1.0 and then the 0.00 column. So if I match it up then, my answer should be 0.1587. Again, you want the negative 1.0 row and the 0.00 column. So you have to match them up together so they make up that Z value. So your probability then is 0.1587. We'll do the next one together too. If you want to pause it to see if you can do it on your own, that's fine. But I'm going to walk through this one together with you too. Doing the same thing. Left of Z equals 1.10. So we're going to go to our table, try to find 1.18, not 1.10. So 1.18. So when I go through this first page is negatives. We don't want negatives, so I have to go to the next page. Next page is positives. So you want to look for your column in the Z that says 1.1 because you always look for the first two numbers. The first number, decimal, second number. So look for 1.1 in our first column, so the Z column. 1.1 then is going to be right there. Now, I need to find 8. So you are looking for the 0.08 column then. So I'm at the 1.1 row, and I want the 0.08 column. Because when you combine those two together, you're going to get a 1.1 plus 0.08. That creates the 1.18. So we have the 1.1 row, the 0.08 column. So it's going to be a 0.8810 for my probability. So 0.8810. Again, it's going to take practice with these. On your web assign, it's pretty much all practicing using your table. So you need to make sure that you are practicing using the table. On your tests and quizzes, I will give you tables. So you will have the table in front of you, but you have to know how to use it. Now you're going to be finding different areas. So here's kind of a picture of what's going on with all of these. I also, in words, if you keep going down, tell you exactly what you need to do because I know this is going to get confusing a little bit when you go through it. So if you see the words left, less than, or see the actual less than symbol, you're going to use whatever number is in the table. You don't have to change it at all. If you see the words right, greater than, or the greater than sign, you have to take 1 minus the number you find in the table. Because if you're going to the right, you have to get rid of all the numbers to the left. The table is the left only. Then for the last one, between. So if you see the word between, or you see less than x less than, you take the bigger number in the table minus the smaller number in the table. So you need to make sure you find your values first when you go through it. Again, 6.2 and 6.3 are both practicing how to do this. So you'll not only have to figure out what your z values are at times, you'll have to also then figure out the probability that goes with it. Now, with your standard normal distribution table, if you have a z value that's smaller than negative 3.49, so if you go through something and you get like a negative 4 for a z value, your probability is always 1. Or sorry, always 0. I'm reading the wrong one. So if you have a negative 3.49 or smaller, so like negative 4, you're going to have a probability of 0 because you're to the left of the chart. If you go back and look at left of your chart, so if I go back here and look at my negatives, the more closer I get to negative 3.49, I get 0.0002. So we're getting closer and closer to 0. So if you're going to go off the page here, you're going to be closer and closer to 0. Whereas if you get closer and closer to the positive 3.49, we're getting closer and closer to 1 here. It's 0.9998 there. So if you have a number bigger than 3.49, you're going to be 1. So if it was like 3.5, it is going to be a probability of 1. So anything outside of that. It also tells you here at the bottom of your chart too, for z values greater than 3.49, use 1 to approximate the area. So it tells you in your picture. Okay, so we're going to practice some more. So for A, we're finding the area between my two values. Now, if we're finding the area between them, you have to find the area of each. So I want to know what is the area that goes with 1.00 and what is the area that goes with 2.70. When I say area, that's the probability. So you got to use your chart. So we're looking for 1.00 in our chart. See if I can get there. So if I want 1.00, I look for the 1.0 and then 00 column. That's going to be a 0.8413. So I'm going to write that down. Now for my next one, I want 2.70. So I'm going to go to 2.70, and I want the 2.7 row, and we want the 0, 0 column. Not the 0.07 column, the 0, 0 column. So 2.7 and then the 0.00. Because really every time you're just looking for the second number in your columns here. So don't focus on the 0 at the front, focus on the second number. That second number should be the last number of your z value. Okay, so I got 2.70. That's going to be a 0.9965. So I'm going to go back here and have 0.9965. Now look at the last page of notes there that we just did. If you have the words in between or less than, you have to subtract. You take the biggest area minus the smallest area. When I say biggest area, that's not the z value. That's your area. So we have to take 0.9965 minus 0.8413. So I subtract those two and get 0.1552. So that would be my area between those two values. Now for B, they want the area to the right of z equals 0.94. So I have a z of 0.94. I want to find the area with it. So first off, just find the area that matches up with 0.9 and then the 0.04 column. So I got to go to my positives. So we want 0.9 and the 0.04 column, that gives me 0.8264. So I'm going to write that down for area. 0.8264. Now, if you go back to the last page that we just did, it says if you see the word right, you have to take 1 minus the value you just found. So if it says right, you take 1 minus the value. So when I subtract those two, then I have 0.1736. Now again, we are subtracting them because 0.8264 is everything left of z of 0.94. If you want everything right of 0.94, you have to find 1 minus what was left. Because if you add the left side and the right side, your total should be 1. Again, these are going to take practice. So if you feel overwhelmed, you need to start practicing on your WebAssign and asking questions with how to do it. Okay, I want you to try these on your own. So I have them now in the inequality form. When it says greater than or equal to or less than or equal to, it's the same thing as greater than and less than. I even have your hints to go through this. So I want you to pause this and do A and B. Okay, so you should have numbers down. Now, it does say shade the area, so we are going to draw the picture with it. It's okay if you didn't, just add it in here. So here's my normal curve. Right here in the middle, that's your mean, that's your mu. So if it says it's a z of 1.15, that's to the right of your mean. Because at your mean, that has a z of 0. That's from the beginning of this section. So if you need to go back through and look at the beginning of this section, that's what it says in that little chart there, that if it's at the mu, then it's going to be a z of 0. So we are 1.15. Now, they want to the right of it. So that means I need to shade everything to the right of that number. So you are finding when z is 1.15, what is the area? So you looked at the 1.1 and then the 0.05 column. So you should have gotten 0.8749. Now, if we want to find to the right, we have to get rid of to the left. Because if you go back to your chart, the picture shows you at the top left corner that it means everything to the left of that z value. If you want right of it, it has to do 1 minus. So when I subtract those two, then I have 0.1251. Now for B, same thing. I'm going to draw my picture. It's okay if you don't have the picture. Just fill it in. So here's my z equals 0 at my mean. I've got negative 1.78, and we've got 0.35. So they are asking for what is all of this in between those two. So when it's between, we have to figure out what are the two areas that match up with our z value. So if I've got negative 1.78, you look for negative 1.7, and then you want 0.08. So the area that matches up with that should be 0.0375. Then if I have a z of 0.35, you're looking for the 0.3 in the z, and then the 0.05 column. So it's 0.6368. Now the last thing you do is subtract. Do not do the z values. Never change your z values. Subtract your a values. Biggest minus smallest. So I subtract those two, and I should have 0.5993. as I keep saying, think about what it means each time. If you're less than, greater than, or in between. Have your notes out. Definitely have your chart out so you can see what your chart says as you go through this. Practice, practice, practice on WebAssign because we're just going to extend this in 6.3. So you really want to make sure 6.2 is good before you move on to your 6.3.